Hello guys, welcome back to the third video in our agentic RAG series. So in this we are going to go over multiple step reasoning capability within an agentic RAG system. So basically in the last video, okay, let's actually talk about the things that we're going to be looking at before jumping to what we did in the last video. So basically we're going to be building an agent, a RAG agent, agent that has the ability to do multiple step reasoning. So what do I mean by multiple step reasoning? So let's say I ask our agent two different questions, question A and question B, and the answer for question B can be found out after answering question 1, right? So the agent needs to be able to break these multiple step questions into smaller steps that it can solve, and after solving the smaller steps, take the output of one step and use it in answering the question within another within another step. So for example, the answer of question B might be found from from answering question A, right? So it first needs to answer question A and then move to question B, right? So that's multiple step reasoning capability, and you're going to do that in this video because traditional RAG systems don't have this capability to answer multiple step reasoning questions. They reason in just one go, right? They don't have the ability to do multiple step reasoning, and that's what one of the advantages of having an agentic RAG system. So let's move on to it and look at the things that we're covering in this video. So we're going to do a recap of the previous video. We're going to do creating of tools, right? Recap of creation tools, which we did in the last video. We did tool calling and other things like that. So we're going to look at what are agents, reasoning loops, what are agent workers, and how it all works at a lower level. Okay, so that's what we're going to be looking at in this video. Okay, so let's look at a recap of the last video. So in the last video, we look at agent tool calling. So the ability for agents to be able to call different tools to perform different activities, such as calling APIs and external data sources and other stuff like that, right? So we look at that in the last video. So if you haven't checked out that video, you can go back and watch that video on tool calling or function calling with agentic RAG systems. So let's go ahead and look at a recap of tool calling. So let me just go back and I'll show you the code for it, because I won't be going over creating tools from scratch again, just to save us a bit of time. If you have any issues, you can always go back and watch the last video and see how we create the tools. Okay, so let's take a look at the code and see how we can create basically tools in Llama Index using agents, right? Agentic RAG system. So this is all we have done in the last video. So I've just rerun the code again from the last video, and I won't be going over all of this. You can pause the video. If you have any question, go back to the last video and check it out. Okay, so we have already covered all this from the last video, simply creating basically a set of tools. We're creating a summarization tool and a vector query index tool. That's basically it. Okay, so a vector query engine, we're using that to create a vector tool, and we discussed all this in the previous video, and you're using that on the LoRa paper that we downloaded previously. Okay, so good. So once we have that out of the way, now let's go ahead and look at what are agents. So far we have been looking at working with Llama Index. So what are really agents, right? We have worked with Llama Index, but really what are agents? So I'll just give you this definition of agents from the official Llama Index documentation on what are agents. So data agents are LLM powered knowledge workers in Llama Index that can intelligently perform the various tasks over your data in both read and write functions. So basically that's basically what an agent is according to the definition from the Llama Index official documentation. Basically, an agent is just an LLM powered knowledge worker that you can use to accomplish different tasks. So they perform automated searches and retrieval over different types of data, such as structured data, semi-structured data, also unstructured data, calling external services such as APIs and doing different stuff. So in this case, an agent I step beyond the normal query engine, in that they can not only read from a static source of data, but can dynamically ingest modified data from a variety of different tools. So building a data agent requires the following things that we need to do. So we need a reasoning loop and a tool abstraction. Okay, that's what I think the two things we need to have according to official documentation. We need a reasoning loop and a tool abstraction. So basically, what are simply an agent consists of are two main things. So there's an agent runner and agent worker. So the agent runner, this is the part of the agent that deals with the task orchestration. So aka task orchestrator. That's what the agent runner is. It just orchestrates tasks, schedule tasks, step queues, and completion steps, what you need to do. Basically, like the operating system just tells what needs to be done, right? Like a boss, you can think of it like a boss in the company. Just schedules things that need to be done, orchestrate all the tasks that need to be done, right? And then we have the agent worker as well. So this actually executes and reasons over tasks. So this is what actually does the task. So basically take different task, reason over them, and then execute them in order to achieve that. So that's basically how the tool and basically a llama index agent data agent consists of. There's an agent runner and an agent worker. The agent runner is a task orchestrator, basically arranges step basically schedule things, and then the agent worker goes over the schedule, reasons over everything, use the tools, the LLMs, the mistrals, the open AIs, and the different tools that provided to accomplish the different tasks that it has over. So it reasons over this, sees which tools it needs to use, and uses those tools to accomplish the different tasks already. So okay, again, you've already created the tools already. So once you have the tools created, now let's move over. One of the things that you talk about an agent worker really needs is the reasoning loop. So what's the reasoning loop? So I'm going to read again this from the official documentation of Llama Index. So the reasoning loop depends on the type of agent. We have support for the following agent, which is the function calling agent and the React agent. React agent is just for reason and acting agents, right? So again, you're talking about reasoning loop, so reason and act agent. The React agent is also the function calling agent, which we have seen in the last video. You can build our own functions and then being able to call them. So now let's look at the agent worker. So an agent worker, basically, as we talked in earlier on, the agent worker is responsible for running all the tools and the LLMs, right? Runs all the tools, basically pick the task from the schedule that is done by the agent runner, and then begins to basically execute those tasks, reasons over them, and then execute them, has access to all the tools and LLMs. So now let's go ahead and build a simple agent worker, and let's see how it works. So this is the agent worker, basically runs all the different steps. So let me just document this right here. I'm just going to say ahead and say agent worker. Okay, so once I have that specified in there, again, if you have been following from the beginning, you can notice I changed a bit of my fonting in VS Code. Okay, so that's really not much of a difference. But basically, what I'm going to go ahead and say from llama underscore index dot core dot agents, I'm going to go ahead and import the following. So I'm going to import function calling agents for function calling. Let me get that spelling. Function calling agent. You're also going to go agent worker. Sorry, function calling agent worker. You're also going to go ahead and say from llama underscore index dot core dot agents. I'm going to go ahead and dot agent, not agents. Okay, dot agent. So this is actually agent and not agents. So let me just correct that there. I'm going to go ahead and import the following. So I'm going to go ahead and import an agent runner. So an agent runner right there. Good. So I'm going to go ahead and create an agent worker, which is basically what actually has access to all the tools, does all the reasoning over the tools, and then does all the execution. So we're going to pass in a bunch of tools. We're going to pass in our summarization tool, which you have right here, and you're also going to pass in our vector tool, which you have right here. And you have also passed in the LLM, which is what we created above right here, right? So you pass in the LLM. Remember we said that has access to the LLM and also the different tools, right? So good. So once we have that specified, we can also pass in verbose, and we can set that to be a boolean true, so we can see the actual output. So once we have this, says missing required position argument prefix messages. So let's go ahead and see if you miss anything. Okay, you need to say dot from underscore tools. Okay, so we need to use this method on this specific class right here. Okay, so once we have that, then let's go ahead and actually create an agent right here, and it's going to be called the agent runner, and you're going to use the agent worker. So the agent runner schedules tasks, and then those tasks are then assigned to the agent worker, which then goes over the reasoning ability and also has access to the LLM, and then use that to execute the different tasks. So once we have that, we can go ahead and run this. And once we have that run, now we can go ahead and ask it any question. So let me just go response is going to be equals to response is equals to, we're going to say agent dot we can say query, and you can ask it any question. So explain, let me just say explain to me what is the LoRa. Okay, today is a bad typing day for me, and why it's being used. Existing solutions. Existing solution is not enough. So something like that. So you can see this is a multiple step reasoning question. So the first thing you're asking it to do is to explain to us what is LoRa. So the LoRa technique, right? And also asking it why are we using LoRa? Why are existing solutions not enough? why LoRa, right? So we ask it to explain to us what is LoRa and why it's being used, and why, whether if existing solutions are not enough, or whether existing solutions can address issues that we have. So okay, so why is LoRa being introduced? Once we have that, I'm going to go ahead and simply do a print STR version of the response right there. So good, let me run this, and this is going to take a bit of time, and you can see here it's using function, calling a function, and you can see it's calling the vector query engine with the argument, which argument is using LoRa and its use cases. So it went ahead and asked what is LoRa, what is the use cases of LoRa, and then it's doing the function output. LoRa can be blah blah, and you can see the output right there. And then it's doing an LLM response. LoRa, which is blah blah, stands for blah blah, and it answers the question right there. So, and it also goes ahead asking existing solutions may not provide some level of experience and efficiency. LoRa effort offers making it valuable technical for various blah blah and machine learning application blah blah. So you can see all that the way it went ahead to answer that question. So it's a step-by-step process that is followed to answer that specific question. So good. That's basically it. And sometimes you might even get better performance from this. I ran this earlier on. I get really good performance out of this. So you can see how you can create an agent and an agent runner. So the agent, sorry, an agent worker and an agent runner, whereby the agent runner schedules a different task, and then the agent worker reasons over picks the task from the schedule, reasons over it, use the available tools, the LLM to be able to answer the available tools, and the LLMs to be able to answer the question. So you can think of the agent runner as the task orchestrator, and then the agent worker as the task runner. Okay, you might confuse those two names, right? Because it's the agent runner, but basically you can think of it like that. Okay. Okay, so good. So once you look at this, we also have Llama Index also provide you the ability to manage memory. So to manage memory, I'm just going to go ahead and copy this right here, and then I'm going to go ahead and run this right here. And I can just go ahead and use the chat capability. And if I use chat right here, it's going to go ahead and all that information stored within memory. But really, I have one question, because I really didn't understand this from the official documentation. And if any of you goes ahead and read the documentation and understand this, please let me know in the comment section below. Okay, so I have one challenge that I really ask myself, because if you run this with a query method, it's saying added user message to the memory, but according to documentation, this is what maintains memory, conversational memory. So I really don't understand, because again, you can see it's asking adding this to memory and using all the tools and all that cases. So why is it saying that? Why the documentation says that this handles conversational memory, but this also looks like it's working with the memory? So that's really something I don't really understand. I will let you know that I have an issue and that get really making sense of that. But basically, that's what they said it does. Okay, so you can see right here, you can see the agent runner like took the task and then went a different way. So you can see challenge it with existing solutions, and it's even a better approach than this approach right here, right? Because it takes understand what is LoRa, and then sees what are the current existing solutions and what are the challenges that they're providing to us that led us to develop LoRa. And you can see it went ahead and answered this question in much detail. And I prefer this way of doing this, because it says what, okay, the existing solution that exists, what are the challenges that these solutions are facing that led to the development of LoRa, right? And then went ahead and answered that question. So if you read the LoRa fine-tuning paper, you can know that the existing solutions such as full fine-tuning can be really expensive. It's basically like training your own LLM from scratch, right? That leads to things like catastrophic memory loss, catastrophic, right? I hope that's the right pronunciation. I have a bit of an accent, but yeah, it can lead to memory loss of a base LLM, a pre-trained LLM, in case if you're doing full fine tuning. But with LoRa, the memory of is basically doing transfer learning, because you're only training some parameters and not all parameters, and help you to reduce the amount of parameters you have to train by almost 10,000 times. So you're only training 0.01% of the parameters than training the whole model, right? So that's the advantage of LoRa, and the challenges that the existing solutions actually face, which is they take much more resources. Okay, good. So once you have looked at that, and we have worked with the agent runner, so now we have understood how all this works. So let's take a look at it. So we have looked into how the agent works from a higher level, from a higher perspective. So let's take a look at how this really works on a surface level. How does it really work under the hood? So let's have a look at how it works in a lower level and gain more control over the agent execution and how tasks are carried out. So this gives us some advantage, such as being able to be in full control of the AI agent, understanding what they're doing, understanding their processes. It also helps in troubleshooting or debugging. Also help us to schedule our own task, right? Because in this case, the agent runner, as we discussed, deals with scheduling of the task, right? So you can actually do our own scheduling. Okay, so let's understand how this works in a surface level. Again, so again, we need this agent right here. So let me just copy this source code, this code from here, copy it. Now I'm simply going to move it and paste it right here. So let's add in some comment right here, and let's say lower level understanding. Okay, so lower level understanding. So I just going to go ahead and run this code right here. So we can go ahead and actually create our own task. Let me just copy this question right here. This question that we have asked, copy it, and I can go down here and I can simply do the following. So instead I'm going to say I'm going to create a task, and this task is going to be, okay, let me get the spelling right. So agent dot create underscore task, just like that. And we can go ahead and pass in the information that we had right here. So we have creating a task, and this task basically answers this question. That's the task that we have. Okay, and again, if you can break this into multiple lines, if you feel like, you can just do this and then add in a new line right here. So this, and then paste this right here. Good. So that's all we need. And you can see I've created the task right here. So instead of now letting the agent run a schedule task for us, we can actually go ahead and manually do that. So you can just simply go ahead and create the task. Okay, so let's run that. So that task is created. So once you have done that, you can go ahead and check if the complete. Let's just check the completed underscore steps of this task, and you're going to say agent dot get underscore completed task, and we need to pass in the task. It's going to be equals to task dot task underscore id, just like that. So you can pass in the task id, and you can print the number of tasks that has been done. So that's basically it's right there. So once we have that, I can go ahead and print. I can say 4. Let me just scroll this up. So it's for step, and then you're going to print ahead and print out the completed steps. And for step, okay, let me just go ahead and say not this right here. I'm going to say for length in completed steps right here. I'm going to check the length. If the length is greater than 0, and then you're going to go ahead and do a print completed steps, and then dot get I'm going to say dot get output underscore output dot source, just like that. And I'm going to say 0 right here, and I'm going to say dot row underscore output, just like that. So that's basically it. So what you're simply doing is right here, I have this highlighted issue right here. So let's fix if I can have that fixed. So for length if the length is greater than 0, we're simply printing out this. So let's see why it has an issue. So it says expression cannot be as assignment target completed task any. So let me see why I've made it. Okay, this is if. So if, sorry, my bad. So let's run that again. So get task 1 position. I mean, let's see it right here. So we're saying completed task 0. Completed steps. Okay, let's say completed steps. We're getting the first element. You're getting dot output dot sources. Okay, my bad, dot sources, and then get the first one, and then do the raw output. So let me run that again. Okay, we still have the same error. So get task completion. Let's see if I've made an error right here. Dot get okay, so I was saying agent dot get completed steps. Okay, completed steps and not tasks. So completed steps. Okay, so once we have that specified right there, you can go ahead and copy this. Make sure I have it copied properly. Paste it here, and let's run it one more time. So right now it didn't have any steps that it needed to run. So number of completed steps, it didn't print anything out. We can also go ahead and print out the task task id, and let's run that. It didn't print out anything as well, because the task here is less than 0. Okay, so let me just have that there, copy this and paste it here instead, and let's run that. So you can see this is the task id right here. Good. So now now that you have done that, one thing you can also go ahead and do, let's see, this should actually have a task. I don't know why it doesn't really get the task, because we have created the task right here, and you're simply saying agent.create task. Let's see why it's not really, because this task should have been here, because it has not been completed yet. So yeah, So let's see if we have that task. So task ID, and we went ahead and got the task ID, print the length of it. The length of it is 0. Okay, the task hasn't been completed yet. Okay, so once we have that done, the task has been completed. So now let's actually run this and make sure the task is complete. So I'm going to add another source code right here. I'm going to say step underscore output. This is going to be equals to agent dot run underscore step, and then finally pass in the task. The task, we're going to say task dot id. Okay, so task dot id dot task underscore id right here. Okay, so once we have that done, I can just go ahead and print the response out there. So I'm going to go ahead and simply say, let's actually run it and let's see what we get back. So let's run this step. So adding to memory, explain blah blah. And you can see it's using it's calling the query engine tool, and then function calling the function function output. This is the function output right here. So now let's check if any of the task has been done. Good. So you can see it went ahead and solved one of the tasks, which is LoRa significance, and then you can see we have this one right here. So yeah, good. So you can see now it's outputted the raw output right here, right? Because one of the tasks has been done. So we have to actually once you create the task has not been completed. So you can get it to this. You can get it this. We can get it from this get completed task method. So you have to actually run run the task, and then finally you can now get the task has been done. Okay. So that's basically how it works. So good. Once you have that, basically that's how it works in the in the background. And you can also check if you can also go ahead and check if you are using this in a fold. Maybe there are multiple tasks that it needed to do, but in this case it only completed one task. So let's check if there is any other task that still needs to be done. So you can just go ahead and do print step underscore output dot is underscore last. So basically checking if that is the last step. So as you can see, it's not the last step. So the other step that we need to complete. So in this case, it only went ahead and found the significance of what is LoRa and its significance, right? So basically, that's only one step. It didn't tell us the challenges that if existing solutions are actually enough. So this is actually existing. Existing. I hope that's the spelling of existing. Okay, good. Let me run this one more time. So you can see right here, it only went ahead and completed one of the steps, and you can see check if this is the last step, and you can see it's false. It's not the last step. This means there's another step for it to complete. So how do you run this other step that it needs to complete? So let's go ahead and run this other step. So again, we go right here, not here. We go right back here, and let's copy this and then bring it right here. Let's see if it runs, and let's check if it's the last step that it has completed. So paste it right here, and let's run. Okay. So what's the next step? LoRa and significance is still the same thing, and then what output, and then let's see if it's the last step. And it says it's still false, not the last step. Yeah, so you can see it's still telling us not the right step. So now one of the ways you can get there is also say response is going to be equals to agent dot finalize. Let's finalize everything. Finalize response, and we're passing in task task underscore id. So basically, you can use this step to be basically to finalize everything. So you can go ahead and print a string version of response. So let's run this. Let's see what we get back. So you got an error here. Finalize can only be called on the last step output. So you can see this is not the last step output right here. So it's not the last step output. That's why we're getting this particular error. So sometimes it really has this issue not picking up the last step. So sometimes you just have to go back and run this multiple times until you're able to run the final step. So let's go and see. If you go back in here, let's scroll all the way here. Let's try to run this. Okay, we still have the same issue right here. So okay, we have to wait for this to run. Once this is ran, it's still saying it's not the last step. Okay, so since this is not the last step, let's try to find out what's the upcoming step. So we can go ahead and simply say upcoming underscore an upcoming step, which is just basically agent dot get upcoming steps, and then finally pass in the task ID, and you can go ahead and actually print it out if it's actually the last step. So I'm going to go ahead and grab this statement right here, grab this for loop, and then simply paste it right here. Sorry, the if statement, and let's try. Okay, this is actually, I need to change this variable from completed task to this one right here, and then upcoming task. So I'm going to change this right here. I'm going to go ahead and say upcoming task, upcoming steps, and I'm going to grab the first one, and I'm going to go ahead and say dot input. So what's this input to this upcoming task? So let's run it and see the inputs there is none. So for some reason, it's not really returning to me the upcoming step. So let's see if it runs again. Let's see if it's completed. If check if it's the last one. Now it's the last one is true. So sometimes you need to find out this upcoming test before you can continue. So sometimes it just has this really issue that you can have to deal with. So you can see now if you call the finalize the response, you can see you have it right there. So one of the issues I noticed is that it's always good to call this upcoming test upcoming to make sure it's none before you can continue. So for some reason you always have to call this thing before it works, else it doesn't work. So I really don't know how this is implemented in the background, but basically every time I run into that error that we went over, so you always have to run this. So I wanted to show you the error that you probably get, because sometimes it's really frustrating and it took me a long time to figure this out, but you always have to run this before you can continue. Okay, so good. So as you can see now, you can finalize, then you can get the final output, which is now the answer for the whole question. So you can see it also include existing solutions, so answered all the questions that we provided. So that's basically now we can actually go ahead and check if this is the last step or not. So you can actually check that if you want. Okay, so good. So once one of the things that you can also go ahead and they can also be human feedback in the loop when working with this one right here, when working with the manual way of the lower level of working with agentic RAG systems. You can also go ahead and pass in a human input. So we can do this actually. You can say go ahead and you can ask a new step underscore output. It's gonna be output. It's gonna be agent dot run underscore step. Sorry, run underscore step, and you can pass in the task ID, and you can also pass in the input to that step that you want to run. So what is the LoRa paper about? So you can actually go ahead and manually pass in different new tasks to the existing tasks that you have created. Okay, so if I run this, let's see what we get back right here. So we got back an issue, a pop from an empty array. So good. The reason why is that this has already been finalized. So you need to run this before finalizing anything. You need to actually run this before finalizing anything. So again, I have to run everything one more time before this can go through. So let me copy that, and let me go in here. So let me see where I can put it right here. Okay, so let me see if I can put this code so that it runs perfectly. So here, let me keep it just underneath where we are creating this task right here. So put it right here before we start running the task. So I run this, goes to run this. Okay, run this. Okay, run this. So you can see pop from an empty array. So dot run steps and then task.id. Let's see what it says. So agent run step task.id, and it says the final output right here. Okay, so let's say pop from an empty queue. So let's see where I probably made a mistake right here. So I've simply created a task right here, and then you have added a new task to the task ID, this specific task ID. Once you have done that, we went ahead and simply run the task right here. You can see summary of the LoRa paper and it's using the query engine tool. In this case, it use the summarization tool, but you can see that's one of the issues it has. And you can go ahead and simply run the task, and you pass in the task ID to went ahead and run that specific task. Good. So once we ran that specific task, and you check print the task ID right there, and you can see its last step is true. So that's the last step that we had to do. So we can't really continue to do any other step. That's why you're getting this error right here, because that's the last step that we needed to do. Okay, because it answered this question previously, it answered that question already, so there's nothing more for you to answer after answering this question right here. So that's the last step. That's why you're getting this error that you can't really pop from an empty queue, right? Because that queue is they're using a queue in the background, because like each question goes inside of a queue, right? And each task goes inside of a queue, right? And you can see we can pop really from an empty queue because we are done with that specific queue. So that's basically it, and that's basically how you can add in your own. Maybe after creating a task and you want to add in a new, maybe a human once has seen the task and wants the agent to perform something else. This is how you can add something new to the task, to an already created task list, right? So you can just add a new task to it, and that's how you can add that to it. Okay, so that's basically it, and that's how you can implement different RAG systems. Different agentic RAG system with the ability to do multiple step reasoning. So you can add in multiple questions as much as you want using this approach right here after creating a task, and all that will be solved at the end of the day, right? So that's basically it for how you can do multiple step reasoning with an agentic RAG system. If you guys have any questions or recommendations, you can let me know in the comment section below. So in the next video, we'll go over the same thing that we did, but now we're going to be using multiple documents, right? So in this case, you're using only one specific LoRa research paper. In these other cases, you might have different PDF documents, different documents from different sources that you want to chat with, and you want to create tools for all of these things. And we'll see how we can be able to do that. And then the next video after that, we're going to go ahead and create a simple project on it, right? So guys, thank you so much for watching, and if you want to connect with me, you can find me on Medium, where I have a written article of this video as well at Prince Crumper. You can find me on YouTube as well, where hopefully where you're watching this video, at Code with Prince. You can find me on X at Prince_Crumper, and you can also find me on LinkedIn at Prince Crumper. And if you have any project ideas, any recommendations, any questions that you want to get help with, or anything that you want us to discuss related with agentic RAG systems, you can always reach out to me on LinkedIn at Prince Crumper. Okay guys, thank you guys so much for watching, and I hope you found value from this video. And if you did, one of the easiest you can support the channel is by liking this video, subscribing to the YouTube channel, and sharing this video with all your friends who might find this helpful. Thank you for watching, and see you in the next video. Keep safe.